We're told that 16 factorial divided by 2 to the power k is an odd integer. So what this question is actually asking us is, if you took all the powers of 2 out of 16 factorial, what would you get? Okay, that's what we've got to figure out. So I expanded it fully. You can do it a little bit quicker, which I'll talk about, but I just wrote it as 2 times 3 times 4, etc. Okay, so I get 1 power of 2 here. I don't get any from this one, and you can kind of see why now you could do it a bit quicker. You can just actually cross out all the odd powers because they're not going to give you any powers of 2. Here I get 2 to the power of 2. Here I just get 2 times 3, so I get 1 lot. I'm just now counting along here the number of powers of 2 that I get. So I get 3 from here, 1 from here, 2 from here, 1 from here, and 4 from here. So 16 factorial is going to be 2 to the power of 3, 4, 7, 8, 9, 10, 15 times an odd number. So clearly I'm dividing by 2 to the power k. It's going to cancel this out. It must be that k is equal to 15. Just before I move on, just a shout out to UKMT for putting this little piece of information in and for Legendre for discovering it. But this is an alternative way of doing this question that I'd never heard of. I did not know this result. It's quite fascinating, I think. So Legendre came up with actually a formula to find the highest power of a prime, p, that divides n factorial. And we use the floor function, which you can read about here. So you basically just take the largest integer that's not x. So if it's 4.1, you take 4. If it's 4.9, you take 4. If it's 5.1, you take 5, and so on. So here's some examples. So Legendre's formula actually says, I don't know how he proved this, don't know where this has come from. That's going to be higher level maths, but it's nice to see the highest power of the prime p that divides n factorial is given by this infinite series. But it's not actually going to be an infinite series because at some point p to the power of k is going to overtake n. So actually it will be a finite series because then we'll always get 0, as it's saying here, once we go above it. And in the case of 16 factorial, therefore, we can, we want to know the highest power of 2 that goes into it. We do 16 divided by 2 plus 16 divided by 4 plus 16 divided by 8 plus 16 divided by 16. And then it would be 16 divided by 32, which would be, with the floor function would give you 0, which is why you only have to add up these. If you do that, we again got our answer of 15. So you might want to play around with it, look into it a bit more. Quite a nice result.